Hello and welcome to this lesson. In our last module, we covered a lot about data visualization and how we should use these in business intelligence. But up to this point, we have not covered a lot about data itself. I would like us to move forward and cover data modeling for BI, which involve learning about the most used data models and how we can use this data model to visualize and create models in BI. Let's start and learn about the type of data models that exist. Let us start by learning about the conceptual data model, which is an abstraction that represents the high-level view of an organization's data without detailing how it will be implemented. It focuses on identifying and defining the essential entities, their relationships, and flow of information between them. And here we have a sample of this model. You can see that we have some subject areas, that is pricing, reservation, partners, marketing, and then we also have leasing and facility. We can see that pricing, reservation, marketing, and partner are related in one way or another, and leasing and facility are also related. Then down here, we have the relationship between payment, customer, and the relationship between customer and the marketing campaigns that can be implemented. This is a simple conceptual model that represents a hotel reservation system. And here we have some of the key components of the conceptual model, which that it provides a high-level abstraction of the organization. That is, it will present the main components of that organization. For example, in this case, we have the key components of a hotel reservation system. Then it also focuses on entities and their relationship and the flow of information. As you can see in these arrows, they direct the relationship between payment and the customer, and the relationship between prospective customer and the marketing campaigns. The main objective of this model is to create a shared understanding among the stakeholders. That is, it shows the stakeholders the relationship between different parts and levels of the organization. Then we have the physical data model. A physical data model represents how data will be stored, accessed, and implemented in a database system. It includes details such as data types, indexes, primary and foreign key, and storage structures. Unlike the logical data model, the physical model is concerned with actual implementation. What we are trying to say is that the physical model will present how the data is stored, accessed, and which tools to be used, or storage facilities to be used in the storage of this data, and how this data will be stored in those storage devices. For example, we have the primary key that will be used to identify unique entries in the storage. And as you can see in this representation, we have data on a product. We also have the stock of this product, and the product will be identified using the product ID, that is the primary key, represented by the PK. This will be integer, and we have the product name, which will be string. We have product code, which will be string also, and we have EAN, which will be string, and we have unitary price. This is will be represented in currency form. Then this is connected or related to the stock that the company has, the stock ID, which is the primary key. The product ID is the foreign key. We also have the warehouse ID, which is a foreign key. Then we have current stock. This is decimal entry. That is numeric entry showing the number of products remaining in the inventory. Then we have the last time this was verified will be represented time and date variable. Then this is connected to warehouse. That is the company warehouse, where we have the warehouse ID, integer, and this is a primary key. And we have the warehouse name, a string value. The key elements of this data model is that it describes how the data will be stored, accessed, and implemented in a database. Then it includes details like the data type, constraints, and indexes, as we have seen in this model. Then it directly influences the database design and performance. That is, the physical model will influence the performance and design because of the primary keys, foreign keys, and how this data will be stored. That is the data types. Then next we have the logical data model. This is a model that defines the structure of the data in terms of table, columns, relationship, and constraints without specifying how it will be physically implemented. It bridges the gap between conceptual and physical data models. Therefore, it translates business requirements into a more detailed and structured representation. And here we have a sample of this model. We have a hotel. That is, we have the property ID, then we have property name and the address. Then in this hotel, we have rooms which have, then the rooms have the room ID, that is the primary key. We have the room number, and we have number of beds in these rooms. And then we have the customer, who is identified by the customer ID. And this is the primary key. We have the first name of that customer, last name, and the middle initial. Then we have the phone number and the address. Note that the logical data model represents the structure of the data without detailing how it will be implemented. And it defines the tables, attribute, and relationship of this data, and acts as a bridge between conceptual and physical models. And here we have an example of logical model, which is a relational data model. And in this model, all the data is stored in various tables. And the example of tabular data in this relational model is as shown below. We have four columns. We have the ID column, we have the name, we have the department, and then the salary of this individual. And as you can see, we also have rows, which are the data entries. And for each row, we have a single record. That is, for example, in this case, the ID is 121. The name is Wu, and this person is in finance department, and their salary is $90,000 per annum. That's a simple representation of data. We'll cover this later on when you are working with database designs. And here we look at, let us look at the importance of data modeling in BI. The first importance is the data models improves the quality of the data by ensuring data accuracy, completeness, and consistency. They also facilitate the identification and rectification of any anomalies in the data. Then the called importance is that they enhance decision-making by providing structured framework for data analysis, and also enables users to make informed decisions based on their reliable information. Then the data models allows scalability and flexibility of the data by allowing easy adaptation to changing business requirements. It also supports scalability of BI system. That is, the BI system may be able to hold large quantities of data or small quantities of data depending on the season or time of the year. Additionally, the data models facilitate data integration, and this is where they help map relationship between different data types and data sources. And so doing, it ensure accurate combination and analysis of data. That's it for data modeling for BI, and this is just a simple introduction. We'll cover more later on.